Welcome to 6.4 Notes, Transformations of Exponential and Logarithmic Functions. So let's just remind ourselves, what is an exponential function? Well, that is simply a function in the form of y equals a times b to the x. A couple restrictions on that you can, if you want to remind yourself why, you can go back to 6.1 or 6.2, but a cannot be 0, b must be positive, and but it can't be 1. And a logarithmic function, again, we're just talking about a type of function. So it is a function in the form of log base b of y equals x, but that's if and only if b to the x equals y. And again, that is something that we discussed in 6.1 or 6.2. You can easily look it up if you need to prompt your memory as to why that's the case. So b is positive, y is positive, and b, again, cannot be equal to 1. And we're just going to remember that a transformation is just a change to the graph. So there might be several different ways that we change the graph, by what we're talking about. So we might decide to change its size or shape. We might end up changing its position or its orientation. So if you need just a quick refresher on, well, how do I change the size and shape? Well, that would just be a stretch or a shrink. Or, well, what does it mean to change position? Well, to change position just means that we've moved it up or down or left or right on that coordinate plane. And then to change its orientation means that we've reflected it. So if we look at this next little chart, this is great to help us remember all the different ways. And you'll notice that these are for exponentials, but they're very similar to what we've done with any other type of graph. So horizontal translation, you're going to have grouped with the x some kind of change, whether it's minus or plus. So here you see up in that exponent with the x, we had a shift that was minus, it moved it to the right, and it was plus and it moved it to the left, just like what we're accustomed to. If we have a vertical translation, it's kind of out on the end and you add or subtract. So here we added 5, we subtracted 1, you can see how that affected it right here. Reflection, don't worry about this one for right now. That's not anything that we're going to be dealing with. So we're just going to look at putting that negative out front. So here it's a -4, and that just reflected it over the x-axis. And kind of the same way that we just did a minute ago, we're going to go ahead and say ignore this. This is not something we're going to do in this Algebra 2, this session. There we go. Oh, I like that. That's much cleaner looking. Okay, so we can go down to vertical stretch or shrink, and that's going to be this number multiplied out in front. So you see here it's a 3, which is greater than 1, so it's stretched. And here it's a 1/4. That's less than 1, but greater than 0, so that shrank it. You know, if it were less than 0, it would just be a negative, and that'd be a reflection. But this is what we multiply to the y values when we graph, and that kind of changes how our graph looks. Okay, now next you're going to look at something and you're going to see, well, it looks very similar, but this time we're going to be dealing with logarithmic functions, okay? So let's go ahead and start right away and just, let's see, are there any that we're going to be taking off? Let's see, we're not going to do it. We do have the horizontal, we have the vertical. Reflection is just, we're not going to deal with this. Let's go ahead and get rid of that. And I'm not going to do a horizontal stretch and shrink. So there, now we won't even be distracted by those things. Okay, so horizontal translation, just like what we're accustomed to, it'll be grouped in with the x. It'll be plus or minus something. So here we had that -4 inside. Here we had that +7 inside with the x. You can see how that changes respectively. Next we have that plus k value out on the end. And we know that when it's not in with the x and it's just out on the end, that will shift it up and down. We have a negative, which indicates to us we're going to be reflecting it over the x-axis. And then we also have, again, that a. We have that a out front that stretches or shrinks. See, the 5 is larger than 1, stretched it. 2/3 is between 0 and 1, so that shrank it. And again, that's when we graph, that's what we multiply our y values. When we graph. Okay, good. So let's dig into a couple examples. Now these examples are going to, we're going to be graphing the functions, and then we will be stating the range and domain of g of x. So first I'm looking at this, and I see that my first one, my f of x here, is 6 to the x power. Well, that's just a standard exponential. I've got my asymptote right here on this axis at, y equals 0. And I know that I can expect to have the point 0, 1, and 1, comma, b. Well, my b is 6. That's my base. So I'm going to go 0, 1, and 1, b. I'm going to hug the asymptote. I'm going to rise sharply, connecting my points. Now I'm going to look at my other graph. My other function here, g of x, is going to give me a graph that's very similar. It's got that same 6 to the x, but here it says it's plus 6. Well, I know that that plus 6 out on the end means that I have to move up 6 units. Well, if I move up 6 units, let's take that asymptote and just drag it up 6 units. Put it right there. And nothing changed to stretch or shrink or anything like that. So I know from this new point, this new axis, I'm going to have those same points. So I'm going to do 0, 1, and 1, 2, 3, 4, 5, 6, probably about there. I'm going to hug the asymptote, curve it sharply, connect those dots, continue on. So it all looks good. You can see you just moved it up. And it wants to know my g of x domain. So I'm going to look at my left value. My left boundary, the farthest left it could possibly be, is -infinity. And there's also an arrow going to the right, so it could go from -infinity to infinity. And you'll see that across exponentials, that's our standard, that our domain is -infinity to infinity. Of course, there can be restrictions placed on it, but nothing that we're going to be dealing with is going to place any kind of restrictions like that on it. Then our range, if we look at our range, well, what is the lowest my g of x can be? The furthest down it's ever going to get is to hug that asymptote, and that asymptote is at 6. And then the arrow on the top indicates it can continue to go on forever. Over here, let's hit that first f of x again. Well, that's e to the x. That's really no different than the first one, but some people might be confused by the e. I just want you to remember that e is just an irrational number. That signifies, for the sake of graphing, it's just 2.7. It is a standard, it's a standard variable we use, just like pi or other things. I guess not a variable, just to stand in a symbol. So I have my asymptote at 0. And I can expect that my first point is going to be 0, 1, and 1 comma whatever my b is. Well, my b is e. So let's graph that, where we hug the asymptote, curve sharply to hit those dots, and continue on. And now for my g of x, let's see how that changes. I have that -4, but it is up in, it's grouped with the x. So that indicates to me that I'm going to be moving left and right. So I know a -4 means I'm going to move right 4 units. Okay, now you don't have to do this next step. I enjoy doing it just because it helps me see things a little bit more clearly, but I'm going to move over 4 units to the right, and I'm just going to go ahead and give myself just a little guideline. So this is my new kind of axis that I'm working from. So I know that this is kind of my new axis between the asymptote and where I shifted over to the right. It didn't change my asymptote, it just kind of moved it over. And I like to do that because then it's easier for me to keep in mind that from there, oh, what was that? Okay, from there, okay, we'll have to fix this out. Okay, so I know that my standard points are going to be 0, 1, nothing made it shrink or stretch. So from there, I'm going to do those same points. I'm going to start hugging my asymptote, sharply curved to go through those points. Looks just like that, so she just shifted over. And again, like I said, we'll find it pretty standard that our domain, well, it can go as far left and as far right as it wants. In our range, it's never going to go any lower than that asymptote. And shift left and right did not change our asymptote on this. So that's going to stay at 0. And so far, so good. Things are going to get a little bit different now, because instead of working on an exponential, we are now going to move into logarithmic. And we know that because it says log. It's really kind of that easy. So our first one, our f of x, is log base 5 of x. Okay, well, I remember that my log is my inverse of my exponential. So if we pause for just a minute, don't write any of this down. Let me just think. If I have, let's say I have my exponential going this way, well, then my log would be going this way because it's reflected over that line. So you see how it just flips over like that's a mirror? Well, that is kind of what we're going to be thinking about here. So things are going to be flipped. When we did an inverse before, because log and exponential are inverses of each other, when we did an inverse before, we saw that all of our x's became y's and all of our y's became x's. So let's see what we're going to do here. Instead of having our asymptote cross that x-axis or cross that y-axis and just sit right there horizontally, we're going to do it the other way. So our asymptote is right here where it says x equals 0. And normally, again, let's think about this. Normally we'd have points 0, 1, and 1 comma b. That's what we would normally have. But we want this to be the inverse of it, so I need to switch that. So I'm going to have point 1 comma 0. And b, well, what's my b? Well, the base is 5, so 5 comma 1. That flipped it. So here I'm going to go right 1 and up 0. Then I'm going to go right 5 and up 1. I'm going to hug that asymptote, and I'm going to curve out to the side, and it will continue going on forever. Next, I'm going to look at this other function, my g of x, and a couple things are happening. In with my x, I've got this plus 7. So I know that means I'm going to be moving left or right. So that means left 7. And out front, I have that stretch factor of 1/2. So let's see, left, well, my asymptote is now this vertical line. So when I move left, it moves my whole asymptote over to here. Did that. And now my stretch is going to affect my y values, right? So instead of 1, 0, 0 times 1/2, well, that's still 0. And then 5 times, instead of 1, what's 1 times 1/2? Well, it's 1/2. So from my new asymptote right here, I'm going to go over 1 up 0. I'm going to go over 5 and up 1/2. Then I will hug the asymptote and I will curve sharply, connect those, and continue going. So you can see it shrank and moved. So now my domain, we can expect this inverse that things are going to be flipped back and forth. So let's see, my domain is no longer negative infinity to positive infinity because I have that asymptote over there. So I know that I will never be able to get any further left than -7, but I can go as far right as I want. And now my range is the one that can go from negative infinity to positive infinity. Okay, let's skip down to number 5 here. And looking at this, my first graph is going to be log of x. Okay, well, log, I know I've got my asymptote right here. So good. And I know that I can expect what did I say a minute ago? Okay, I can expect 0.1, made the erase. I can connect 1, 0, and whatever the base is. Well, what's my base? It doesn't say anything. So I know I'm dealing with my common log, and that's going to be a 10. So I'm going to go over 1 and 0. I'm going to go over 10 and up 1, be right about there. I'm going to hug the asymptote, curve sharply, connect those points, and continue on. Now the next one, my g of x. A couple things happen. Grouped in with my x, I have a -2. Again, that indicates that I'm moving, oops, I hope you caught that I made a mistake. That's not left. That is moving right 2. And then I've also got that 3 out front, so I'm going to stretch by a factor of 3. And that negative means it's going to be reflected. Okay, so let's see, let's start by moving right 2. Well, right 2, it's going to move my asymptote to the right 2. Okay, and then I'm going to stretch by 3 and reflect it. So let's just take that -3, and we're going to multiply that times my y's. So I'm going to have 1, 0 times -3 is still 0. I'm going to have 10, 1 times -3 is -3. So I'm going to go ahead and start from this point and count these spaces out. So I go right 1 and up 0. Then I go right 10, right over here, and down 3. So it's over here now. Well, see, this is that reflection. I'm going to start away from the asymptote instead of starting hugging it. And I'm going to connect those points, and then I'm going to hug the asymptote and continue on. So like the other one, I'm going to see that my domain is no longer negative infinity to positive infinity. The farthest left that blue graph is ever going to be able to get is 2. But it will be able to continue on forever. And like the others, my range, it can come from as far down and go to as high up as it wants. And just remember that your logarithm and your exponentials, they're inverses of each other. Okay? So remembering that, let's take a minute and kind of go back to this thing that we know how to do. Find the inverse. We've done that before with that method that we call swap and solve, where we swap our x and y and then we solve for the y. So we're going to do that here, but this time we're going to have to remember how to rewrite things as logs and exponentials. So I'm going to start with x equals 15 to the y power plus 10. I'm going to do what I need to do to get that y by itself. So I've got to this point. Hopefully we can all kind of breeze through that pretty quick. But now I can't just root this, or I can't divide this or anything like that, because I don't know what that exponent is. So I'm going to undo it by taking it from its exponential form. I'm going to get my logarithm. So I've got my log base. Well, the base of that is 15, and I know that x minus 10 is what that equals to. My exponent is y. Well, I got y alone, which is what my goal was. Good to go. Now over here, if you notice, we have an ln, and that looks a little bit different, but that's really just a log with a base of e. So that's our natural log. So we've got our natural base e, and our natural log is ln. So let's go through that same process that we just practiced over there. Do what we need to do to start getting things alone. We're going to isolate that log. So I'm going to undo that log by putting it in exponential form. So the base of this we know is e. We just talked about that. And so we've got e to the x plus 8 equals 2y. And we are so close to being done, but we've got y by itself, but there's 2 copies of it over there. We need to isolate just 1 copy. So let's go ahead and divide both sides by 2. So y equals 1/2 of e to the x plus 8. So it can be written like this, or it can be written where you've got just your e to the x plus 8 over 2. Those both mean the same thing. Now on your assignment, you're going to have the notes. We have a few more graphs that we can do, but I want to make sure that we're covering everything that I want you to be working on. And so what's important to me is that you be able to see what the translation is, or I'm sorry, what the transformation is, what the equation of the asymptote is, and then what the domain and range are. So just looking at this, we could graph the function, and we could do all of those things, but I think that we can do that just by inspection, basically. So first, let's see, what am I going to ask for first? The first thing I'm going to ask you for is what transformation is taking place here? Well, grouped in with my x, I've got a plus 1. So I know that that means I'm going to shift left or right. And then it's left. And then next I'm going to ask, well, what is the equation of the asymptote? So let's just kind of think about that for a minute. With a log, I know that my asymptote goes up and down, right? So when I moved to the left one, that actually did move my asymptote over left 1. So the equation now, instead of going through at 0, 0, or instead of going through at x equals 0, I now go through at x equals -1. And then what is my domain? We can see there it's never going to cross that asymptote, but it can continue on. And what is my range? Well, we know its shape allows it to go from -infinity to infinity. And then finally, let's do that last one. Again, it's a log. So we're going to kind of have that same basic shape. So let's see about that. We've got that same basic shape. So what transformation is it? Well, I've got a -4. So I know it's going to go down 4. The equation of my asymptote, well, moving it down, it's got an asymptote that goes this way. So if I move it up or down, that doesn't change my asymptote at all. So my asymptote is still crossing the x-axis at 0. My domain, well, like I said, it can't cross that asymptote. And then finally my range. That's not restricted at all. It can go from negative infinity to infinity. And now you are fully equipped to do all of the practice problems that we've set aside for you. Good luck.